In this video, we're showing you how to use the geometry optimization technique within the CM quantum. Okay, so we begin with building up a molecule using Avogadro software. Okay, in this case, I'm going to simulate the chlorine ion. So we don't want the we don't want the hydrochloric. We want just only the chlorine ion. So what I do is I'm going to the selection tool and click select the hydrogen atom and push backspace to delete it. Okay, and then back to the drawing tool and choose an oxygen in order to draw a water molecule by just clicking and doing the optimized geometry to get the right orientation of the hydrogen atoms. Okay, and then I go to File and Save as a water Cl, water and chloride, and use the file format XYZ, and I save that. Okay. Then after that, we are going to use these XYZ coordinates to be the input coordinate in CM quantum. Okay. So now we open the command prompt in the folder and we run the CM quantum. So the structures that we are inputting is water, chloride, and we choose the basis 321G. And then we choose the option opt for geometry optimization, and we can set the up max or the maximum step of optimization to be very large, like 500. And we request the program to output the density for us. Okay, so now just click and enter. Okay, so you can see that the program is trying to do the loop of the SCF alternating with the force calculation and the loop for the geometry optimization. And then when it finishes, is writing the coordinates and the electron density into the volume.xsf as usual, and in which we can open it with VMD software. Okay, so we do the same again. We trying to drag the volume file okay, and we can now open the optimized structures. Okay, so what we can see, okay, so if I change the representation to use van der Waals, okay, and we're trying to get the sphere radius to be a little bit smaller, to be 0.7, and we increase the resolution to be like 30. Okay, what we can see here is instead of we seeing a water molecule and a chloride ion, what we see is the O and H, or the hydroxide ion, and the HCl, or the hydrochloric, instead. Okay. So what happened over the course of geometry optimization is you can try to right click and load data into molecule. Okay, and then we are going to load the starting structures. Okay, so the starting configuration of this system is the water ClXYZ. So I'm loading this into the molecule 0, and I click load. Okay, so what we see here was the initial configuration generated by us. Okay, and if you try to click this button, click the step forward button, so what you can see is the final state after the optimization. Okay, so the first stage and the after stage are actually the proton transfer reaction. Okay, that when you allow the quantum mechanical calculations, what you can see from the calculation is the hydrogen tends to be deposited at the at the chloride to make the hydrochloric acid. Okay, and that is one of the example of using geometry optimization, and you can also see the effect of the proton transfer between the water and the hydrochloric.